So basically, if I say there is a matrix A, it can be any size, right? 1, 2, 3, let's say 4, 5, 6. What is the size?
3 by 2 or 2 by 3
Rows into columns. Okay.
columns.
Rows means horizontal. How many horizontals are there?
3 by 2.
Horizontal. There are like,
Oh,
you have
sorry,
to count
2.
these lines. Horizontal
2 by
lines.
3. Yeah. The column is 3.
Column means these vertical lines. How many are there? 3.
3.
So 2 into 3 is size. Number of elements is equal to
6. 6.
6. 2 3s are 6. And let's say if I ask the value of, what will the value of 2a? Twice the matrix A.
You have to multiply 2 by each and every element.
Each and everything. Nothing is left. So 2, 4, 6, 8, 10,
36.
12.
Oh, 2. Okay. Not square. Okay.
And one more thing. A square means not 1 square, 2 square, 3 square. That is a different thing.
Oh.
This is not the same. So when you are multiplying, this is called scalar multiplication. Scalar means a number, numerical. So this is about multiplication. Let's say there is a matrix A, 1, 2, 3, 4, 5, 6, and there is a matrix B, 4, 5, 6, let's say 1, 2, 3. What will happen when you add A plus B? What do you get?
5, 7, 9. 5, 6, 9. 5, 7, 9.
5, 7, 9. Okay. Yeah. So
Is it
basically,
correct?
yeah, that is correct. So you have to add this corresponding elements. Corresponding position elements are added. But one thing we need to be careful is when you are adding any type of matrix, this with this, so you have to make sure that the size is the same.
Okay. The
You
type.
can,
Yeah.
let's say this was A, you cannot add with 3 by 3. Makes sense, right? It doesn't match. Corresponding elements don't match. So is not possible.
Yeah.
Addition or subtraction. So subtraction means
Minus.
minus.
We have to. Yeah.
So first minus second.
Mm.
So can you say if A minus B is equal to B minus A for matrix?
E minus B. E minus B equals to. No, it won't be same, right?
Not necessarily, right? So it won't be
No.
same. So it is not commutative.
Yeah.
So subtraction of matrices is not commutative.
Committed.
But addition is
Committed.
commutative. Multiplication is not necessarily commutative.
In multiplication, you will get the same value, right? Even you do A into B or B into A.
No. Multiplication of matrices is a bit different. When you are multiplying A with B, multiplication, let's say size of A is M into N. Let's say B is A into B is the size.
It's possible. it is possible to multiply.
There is a condition. It is possible to multiply
Mhm.
only when these two numbers are equal. N is equal to A. So it's like you can multiply a matrix 1 cross 2 with 2 cross 3, 2 cross 4. It's just that these two numbers have to be the same.
Okay. Column should match.
Answer will be a matrix of order 1 into 3 of size 1 cross 3. So two things. These middle numbers have to be equal.
Mhm.
Next thing is these answer. This will be the size of the answer.
Okay.
So let us see how do we multiply matrices. Let's say I take simple example 1 into 2. Let's say 1 comma 2. This is 1 into 2 size, right? Two into 3 means, let's say 1, 2, 3, 4, 5, 6. Try to multiply A and B. So it will be 1, 2, 1, 2, 3, 4, 5, 6. There is a pattern to multiply things. So first element in first matrix multiplies with this,
1.
and plus 2 into 4.
Okay. So row with the column.
So 1 into 1 plus 2 into 4. Yes. This with vertically. Row with
Okay.
column.
Column.
So this is the first element in the answer, multiplication. What will be the size of the answer?
Sign.
Size.
Size. Okay.
Size of the answer will be what?
2 by 3.
1 by 3. So this is 1 into 2, right?
Okay. So we will multiply 1 with 1, 2, 3, and 2 with 4, 5, 6.
Size means like this size 1 cross 2, 2 cross 3.
Oh, okay. Yeah, that's what I'm saying. So we only multiply 1, 2, 3.
1 cross 3 is the size. This and this last one. Do you understand?
1 by 3.
Here I have discussed. Answer will be of size 1 cross 3 like this.
Mm-hmm.
So 1 cross 3.
1 means row and 3 means column.
Yeah. So 1 row, 3 columns. So basically there are still 2 other entries which we need to find, correct?
Okay.
So this value is how much? First tell me this.
1 plus 8.
9, right?
9.
Yeah. So the answer will be 9. Next will be, next element can be obtained by,
Oh, so we have to 1 into 1, 4 into 2, and multiply. Okay, got it. So 1 into 2, 2, and 12.
2 into 5. So 12.
Yeah.
Next thing will be obtained by
2 into 3, 6 into. No, 1 into 3, 6 into 2. So 3 plus 12, 15.
Okay, 3 plus 12 is 15. So this is the answer. The size is also 1 by 3.
1 by 3, okay.
Okay. This is how you multiply. Row with columns.
It's kind of confusing.
Yeah. So let's say We multiply 1, 1, 1, 0 with root 3, 2. Try this.
Root 3 plus 1.
Root 3 plus 1.
Then
Like this, right?
yeah,
Next.
it's confusing a bit.
Yeah.
Okay. 2 plus 2.
It's like the way I see it is, let's say you put a pen like this
Hmm.
and then you rotate it and put it vertically.
Hmm.
Put the pen on this, pen on this, and pen on this.
Hmm.
So first,
So we have to multiply 1 1 with all the columns first.
yeah, 1, 1,
Then we have to multiply second row with all the columns.
this with, now again, this,
Okay.
this.
Okay.
So first one is root 3 plus 1, that is correct. Next.
Okay. So second one will be 2 plus 2, 4.
2 plus 2. Okay.
And third one will be 1 minus 1.
Correct. Done, right? Done with this batch.
And then root 3 plus 0.
Yeah, root 3 plus 0.
Then 2 plus 0.
2 plus 0.
Then 1.
And then 0. Okay. This is the answer.
Yeah.
Multiplication of matrices.
How do we write root 3 plus 1? Root 3?
We leave it like that.
Okay.
Root 3 plus 1. So if you want to add 2 plus 2, 4. 1 minus 1, 0. This is 2. This is 1. This is root 3. So I'm not writing that.
Okay.
Comes to types of matrices.
Mm-hmm.
See, if I write only a matrix with just a row, okay, there is no column, right?
Yeah.
So this single row, single column, single row matrices are called row matrices. We call this as row matrices. Column matrices means only one column.
Yeah.
1, 2, 3, 4, 5, 6, doesn't matter the size. And there's also one more thing, diagonal matrix. It's just that in a square matrix there are only diagonal elements are present.
1 1 1 diagonally.
See, if it is only 1 1 1, it will be identity.
Oh yeah, identity. Okay.
But what if they are not always 1? Let's say 1, negative 1, 2, 3, whatever the number they wish, like this. This type is called diagonal matrix. Diagonal elements are available.
Mm-hmm.
Apart from that, everything else will be
0.
0. I think that's it. So these are some basics of matrices. And one more thing was about that. Yeah, we'll discuss about equality of matrices. Yeah, equality of matrices. It's like equations. Okay, hold on. Let's say if two matrices are equal to each other, or let's say A is equal to 2B, things like that. So let's say B is equal to a square matrix, or let's say some random matrix 1 2 3 4 5 0. So what will be the matrix A if A is equal to 2B?
Then we have 2 multiply 2, then it will be equal to A.
Okay, let's say A is given as A B C D E F is equal to A. What are the values of A B C D E F?
Then A will be 2, B will be 4, C will be 6, D will be 8, 10, and 0.
Like this.
Yeah. So we have to write like this. Okay.
Yeah, I mean, in the question, if it says that A B C D A,
I just you write in the.
yeah, you have to fill this table if the exam if they ask. So 2 4 6 8 10 0, like this.
I don't think they will ask this. This is a question. I saw one person commented on one of the posts of Bits Bilani. They said the exam is pretty easy.
Exam is easy?
Yeah, I don't know. I mean, they said like that.
Okay, why is that? Is it specifically this time?
Find x, y. If x plus y is
Yeah, x plus y is given. X minus y is also given. See, if there are these two equations, two variables, x and y are the variables. What happens if you add these two equations? This plus this entire thing.
8808. Oh, that too. It is -1, right? Not -2.
-1. Yeah.
Yeah.
Yeah, 8808. And on the left side?
X plus y plus x minus.
So did you observe something? Y and y are?
Y will 2x.
2x will be left on the left side. So x will be half of this matrix. So it's like just as you, if there was 2, you will multiply, right? 2, 2, 2, 2. But if it is half.
4404.
This is the answer, x. How do we find y now?
We'll put a y. In total, we will minus 4404.
See, x was this much. So you plug it back into the original, any one of this or this relation. Any one of the relation. X and y should satisfy like this type of relation, right?
So we'll minus x minus 360 minus 1.
So plus y is equal to 5209. Okay, let's say 3609. Negative 1.
Okay. So we'll take y to other side.
So negative y, right? So
Yeah.
if you take y to the other side, y will be on this side. But you have to take this
3601. Signs will change.
Like this, minus 360 negative 1. Okay. What will the answer for y?
1 2
1
0 4 minus 3.
4 minus
3.
Not minus 3. 4 minus 3 is 1. Yeah, I have written here.
1 2 0 3.
Like this you are saying? See, 1 and 0 are correct, but 2 and 3 are wrong.
Oh, -2 plus 3.
Yeah. 4 minus 6, right?
Minus 2.
And
3.
4
Minus
minus of minus 1.
minus plus, yeah. 5.
Okay. So that is a y. So x and y, did we find? That is the answer.
Yes.
Continue with matrices. So some of the basics are, let's say a is equal to 1, 2, 3, 4.
Mhm.
We already discussed a square means not 1 square, 2 square, 3 square, 4 square.
Also,
This is not. A square is not like that. A square means a multiplied by a. Okay.
okay.
So 1, 2, 3, 4 multiplied by 1,
So 2, 3, 4.
2, 3, 4. Can you find the answer?
1. Okay. 1, 6 in
So
row. Yeah.
1 plus
1 and
6.
1 plus 6. Okay. 7.
Next.
Then 3 plus 6. 9.
3 plus 6.
We have to. Okay, row with the column. I was doing column with the row. Okay. 2 plus 6. 8.
2 plus 8. 2 plus 8.
First row with the first column.
This with
Okay, first row with the second column. Okay.
this.
Okay. 2 to the 4. 4 to the 8. 10. Okay. Then 3 plus 12. 15.
Yeah. Pen like this, pen like this. So 3 plus 12.
Okay. Then 6 plus 16.
Like this. So 6 plus 16. Simple.
16. 22.
So 12 and then this is 15.
Hmm.
So this is a square. You see how it is not 1 square, 2 square, 3 square, 4 square.
Hmm.
A square value will be something else different.
Different.
Okay. And any matrix, if you multiply with identity matrix, A into, let's say, I. Okay. A into I. This will be equal to itself only. Identity matrix. The result will be like this.
Mm-hmm.
Even if you take I into A, the result will be same.
A.
And regarding transpose, some textbooks show that AT stands for a transpose of A. But some textbooks, they write, instead of AT, they write like dash or prime. You can call it A prime. Transpose symbol notation.
Sorry.
So there are some properties for transpose. I mean, if two matrices are multiplied, but if you take the product, if you take the transpose of the product, it will be like B dash A dash.
So first we have to multiply or first we have to do transform?
I mean, even if you multiply this and then you take the transpose overall, it is the same as B transpose multiplied by A transpose. Same thing. It's just that properties of transpose, specialty of transposes. So A, B, C multiplied transpose means a reverse order like this.
So how in this case how we will multiply A into B and then AB into C?
Yeah, A into B, if there is a product, then you can multiply it with C.
C, okay.
What will be the order of D?
Order in the sense of size?
Size, same thing. Size,
Yes,
order.
This one, 2 into 2.
2 into 2, right? Everything else is 2, 2, 2, 2.
Yeah.
So you are doing subtraction. That means subtraction is possible when orders are same. Addition, subtraction.
Mm.
So yeah.
Of B.
Yeah. A into B, right? Not B into A.
Yeah. So 2 into 5 and 2 into 7
So you
and
write first side by side. A is on the left, B is on the right. Correct?
yeah.
So this with this.
Yeah. So 10 minus 7, 10 plus minus 7,
Which is
3.
and
And then minus, no, and then 3, 4, second row with second column.
no. We are still talking about this only. So
So
don't
we
leave
did
this until we
now we
complete
will
this like
okay.
this.
Yeah, now we will do one. Okay. So minus 5, minus 7. So minus 12.
So this with now this.
Oh, okay. It's confusing. 4
Hmm.
and minus 4.
Okay.
0, yeah. Then second row, first column.
Yeah.
15 plus 21.
15 plus. So
21.
15 plus.
Oh, yeah. 28.
Which is so this with this is done.
43.
Yeah. 43. So this with this is done. So this with
2 and
now
4.
yeah.
2 and 4. So 6 plus 16. 22.
That's it. This is the AB value, AB product.
I keep forgetting. 2 minus. Okay. And now C and D. C.
Hmm. C on the left, D on the right. So C on the left. D was
ABC. So it will be 2A plus 5C.
next.
And then it will be 2B plus 5D. 3A plus 8C. 3B plus 8D.
So this was CD, right? So can you guess what to do next?
Yeah. It will become a equation now.
CD minus AB was
CD minus AC.
AB was
2A plus 3C. 2A plus 5C.
it is given that it is 0. 0 means what? 0 matrix. This O is a bit
It's
capital, right?
0. Okay.
Means it's like 0 matrix.
Everything will be 0. Yeah.
So capital O, that is O, 0 matrix. So CD this minus,
AB.
right? Can you write?
Yeah.
Okay, this
Minus
is correct. 2a plus 5c minus 2.
Yeah.
So, so this minus this, right?
Yeah.
So 2a plus 5c minus 3. Okay.
Hmm.
And 2b plus 5d minus
43.
minus 0. So top right, top right.
Oh, we are doing subtraction. We are not doing multiplication.
This minus this.
Yeah. I mixed up.
Okay. And then subtraction, addition is simple. Then multiplication.
Okay, so 3a plus 3c minus 43.
Minus 43. That was 8c.
Yeah.
And what else?
3b plus 8d minus 22.
So this should be equal to
0.
so 0, 0, 0, 0. Can you guess what's next?
Mm.
See, if two matrices are equal to each other, this matrix and this matrix are equal to each other, means corresponding elements match each other. Like this.
But it is not matching, right?
I mean, we have to write. So 2a plus 5c minus 3 should be equal to 0. This is the condition we are getting.
Mm.
And
But
what
it's
can
not.
huh?
But it's not, right?
I mean, we have to do it like this. So equate that to 0. And then
Check
this
it. Mm-hmm.
3a plus 8c minus 43 should be equal to 0 like this. And also from these two conditions, 2b plus 5d is equal to 0.
0, yeah. We have to make an equation.
Yeah. So two equations, two variables, two equations, two variables. A and C, B and D, separate, separate.
Yeah.
So if in the exam ABCD values are given, you can just plug and play and check which one is satisfying the answer. Which one is satisfying the equation? Which answer is? What type of format is it exam? Multiple choice or descriptive?
What type of?
Format. Is it multiple choice? Or you have to write the answers?
No, multiple choice.
Yeah, so basically what I was saying was multiple choice means ABCD options will be given, right?
Yeah.
So if they give answers, A value, C value,
Mm-hmm.
you can just plug and check which one is the right answer. Instead of finding all those.
It equals to 0, then yeah, it is.
Yeah. So remaining part of this question, try it as homework. So find ABCD values.
Okay.
We'll move on to the main topic, which is the next question, this one.
Hmm. But to find the value, we need to have one value, right?
Find the values of x, y, z, w. Okay. Uh,
Stands as in?
Yeah, it lies on first row, right?
First row.
So write subscript 1. and it lies on what column?
First column.
So this is called A11. The first element is called A11.
Uh,
So usually they represent elements as Aij.
I will be row and J will be column.
I will be like row, number, or position. J will
J will
be
be column.
representing column. So can you spot like A23? Spot A23.
Second in the row and third in the column.
So in the diagram, where is it?
The bottom side, middle. This row. Three column, three.
See, that is
Second
not.
row, third column.
See, row means like this. So
Yeah.
this line, in this line, third
Oh
column.
yeah.
See, the way I
Row.
remember row and column is, it's like you write row like this, right?
Mm-hmm.
So it's just that sometimes we write W like this, right? So it's like horizontal.
Horizontal.
Column means you write N, right? Like this.
Mm.
So you
Vertical.
and next one vertical.
Okay. Second row, third column. This one.
This is A23. Okay. So like that you can fill the column. Can you guess what will be this?
A 3 column 2 3 2.
3 2. So along this diagonal it is like flip inverse. 2 3 becomes 3 2.
Mm.
So A23.
In inverse.
No, not inverse. Along this diagonal, if you see there is a
Why?
pattern, symmetry pattern. 2 3 becomes 3 2.
Oh, okay, like that. Okay.
What about this position?
It will be second row, first column.
So 8 2 1. What about this?
Third row, first column, 3 1. So 1 2 3.
Like this. Can I write like this? This is A13.
Yeah.
This will be A12.
Yeah.
This will be A22.
Yeah.
A33. So in the diagonals, I is equal to J. If they want to write in a fancy language, diagonal elements are represented by
A into J.
Aij, where I is equal to J. I and J are equal. Diagonal elements are represented by Aij, where I is equal to J.
J. Yeah.
So if it is on the first row, A11, second A22, third 33. Okay. And that's it. So that is for section 1. Let's say A is equal to, let's say 1 2 3 4. What will be the value of A plus I whole power 3?
No, it will be 2 2 3 5. A plus I.
So this is A plus I.
Yeah.
So iska cube.
Yeah.
So do you remember it is not like this?
3 times. Yeah. No, we cannot do that.
Yeah. So it's
So
like
we have to multiply 3 times. Yeah.
so first do these two things and then
Then-
the answer with these two things.
Yeah. Row
Yeah.
with the column.
To be more precise, it's like A plus I, A plus I, A plus I. Like this.
The answer will be the same.
I mean, it's not like A. It's like we are adding I, right? So yeah. So a plus I will be this. So 2 2 3 5 2 2 3 5 2 2 3 5 three times.
Hmm.
2 2 3 5 2 2 3 5 like that. So first two products will be answer how much, right?
So 2 to the 4, 2 to the 2 3 are 6.
So 4 plus 6 is 10.
Yeah. And
Next.
then 6 plus, oh yeah, the same with this one. Okay. 4 plus 10, 14.
Yeah, 14. Next.
Then 6 plus 15,
Hmm.
21.
And
And then 6 plus 25, 31.
okay. So this is a square value.
Yeah.
And
And
for this you need to,
yeah, multiply with the 2235.
yeah, it's not like we need to multiply like this.
No,
We have to do with 2 to 3 5.
35, yeah. So it will be 20 plus
20 plus
10 into 2, 14 into 3, 42 plus 10, 52 or 60, huh?
62. Okay. Next.
14 into 3, right?
Hmm?
14 into 3, oh, okay, 20, okay, it was 20. Then 20
Hmm. 20 and
plus 20,
20 plus.
90, 70.
So it's not, see, like this,
Four-
like this.
14 into 5, right?
20. So 20 plus 70 is
90.
next.
Then 20 into 2, 42 plus 155.
It's not 155. How it is
Oh,
150?
3. I did wrong. 93.
See, H and V, horizontal, vertical, horizontal, vertical. Horizontal from the left, vertical from the right.
42 plus
42 plus
93.
is
135. 135, right?
oh, yeah, 35. 135. Next.
Then 20. 42 plus 197.
Okay. So this is the answer. A plus I whole cube.
Hmm. Hmm.
Yeah. So that's about section 1. There is one concept, it's like a theorem, if you want to call it. Any matrix can be represented by, any matrix can be represented as a sum of symmetric and skew symmetric. Any square matrix can be represented as a sum of some random symmetric matrix and skew symmetric matrix. Okay, let's say A is a square matrix. Okay.
Mhm.
My question is whether A plus A dash, is it symmetric or skew symmetric?
What was that in skew symmetry?
So if you take the transpose, you'll get the same thing. So if A dash is equal to A, it is symmetric. But if A dash is negative A, it is skew symmetric.
Skew symmetry. Okay.
So what we need to do is, this is the main layer, right? They are asking whether this is symmetric or not.
Mhm.
So that means you have to take transpose of this entire thing. So A plus A transpose the entire thing. So it will be like A transpose plus A transpose transpose.
Okay.
A transpose transpose means itself only.
Oh.
So you see this A plus this and this same thing.
Mm.
So transpose of this was same thing. So it will
This
be,
one. The same.
so it is called
Symmetric.
symmetric matrix. Okay. And what about A minus A dash? Whether it is symmetric or not symmetric, which one is this?
Skew symmetric.
Okay, how?
Because of minus.
So if you take, we are talking about A minus A dash, right?
Mm.
So we have to take transpose of this. So it's like A dash minus
A dash. The A dash dash.
A dash dash. So A dash minus A.
Mm.
So do you remember, if you take out minus, it will be,
Plus.
so minus A dash plus A.
Plus A. Yeah.
So if you want to rearrange, A minus A dash, that is. Okay. So minus of A minus A dash means minus of the original one.
Yeah, it's the same. The same thing, right?
Thing but minus.
Yeah. So skew symmetric.
Minus of A minus A dash.
Yeah.
So skew symmetric. So the thing is, the earlier have told you this. Any square matrix can be represented as a sum of symmetric and skew symmetric. So it's like A will be equal to A plus A dash plus A minus A dash half. So it seems like the character limit has been reached.
No.
So that is why.
Is that a formula?
Yeah. Theorem.
Uh-huh.
A plus A dash and A minus A dash. I'll send you a picture.
No problem.